Uh, I'll come on to evolution of quality. Just to set background of what is the quality and how it has evolved over a period of time. So so quality, it started way back when before the industrial revolution. So what used to happen is there was one of the kind goods or the product used to get produced. So what was happening is there was a one craftsman who would produce a product, or who would prepare an artifact, and then the artifact would have a buyer or a consumer. The only way to check quality at that point of time was through inspection. So either the craftsman who was doing the production would do the inspection, or the consumer who's consuming that particular product would go ahead and do the inspection, and then eventually figure out whether it is a right quality product or a good quality product or not. So the only way to check each and every item, each and every product that used to get produced. So it was working on fine till the time the production rate was quite low. It was one of a kind product used to get produced. Now with the industrial revolution, what started happening is that the same product used to get started to get produced in thousands. So what has happened at that point of time? It became really difficult.
You're cutting out. Are you there?
People started realizing that they need to start worrying about the process as well. Now, the inspection cannot be done for everything. So how do we know that whatever we are producing is the right quality or right quality product or right quality artifact or not? So then, they started looking at the process, and they realized that every process would have set number of inputs, and these inputs, I'll just use my screen. Okay, I have it there. So, so assuming this is a process, right? So every process would have certain input. We'll have input A, input B, input C. Okay, so what is a process? Process is a set of activity, repeated step which converts these input into an output, right? Uh, Scott, you can still hear me, right?
Right. Yeah, you cut out there for a minute, but I can hear you again.
Oh, okay, right. So doing live online can be a bit tricky sometime.
Right.
Get disconnected in between, and as a trainer, you don't get realize that because you're so engrossed in the slide, you don't realize that you're cut off.
Exactly.
So, so that's the reason in between I'll keep on stopping and checking with you if you're still there. Okay, so coming back to the process, every process would have certain inputs. So in our example that you see on your screen, there's an input A, input B, input C. Now these input can be broadly categorized as controllable input, but there can be some non-controllable inputs as well. Now these non-controllable inputs are also called as noise. So I am depicting it by small a, small b. Now what is happening now is, so the process is not only dependent on these controllable inputs, but also on these non-controllable inputs as well, on which something, which we don't have any control on. And the output is largely dependent on these inputs, and sometimes due to variation in these input and in the process itself, instead of getting one single output, what you would get is a distribution. So again, I will. So for example, so let's say we wanted output at this particular point. Now, because of variation in the process, we sometime might get on output here, sometime we might get output here, sometimes here. So all I'm trying to say, there would be a variation, right? So instead of getting one output, what you would get might be a distribution. Now distribution is, so let me just open Paint. So it might be something like this. So this is my x's, and these are the distributions. So we have all the outputs here. Have you seen this distribution, or have you heard about this bell curve?
Mm-hmm. Correct.
Right. So bell curve is nothing but a distribution, right? So so in statistics, what they say is, when you study the process for a long period of time, you would not. There's no way you can get all the output or all the data points at exactly the same point. There would be some amount of variation which will always be there. And because of that variation, the data will form a distribution. So what essentially, because of this distribution, what is happening is that outputs are at the different measurement scales. And what it is showing a variation. It is showing a variation. So what is happening now is, many times what is acceptable to the customer is not what is always delivered by the process, which is anything beyond the acceptable range provided by the customer. Again, taking the same example of that bottling plant, and so let's say this is the specification given to us by the customer. Okay, so this side right here, sorry, this right here is the upper specification.
Mm-hmm.
That the customer says that it should not be above this. So in our example, let's say 201, and just bear with my, I should not say handwriting. In fact, my handwriting is as terrible as this. So
A little tough to write in Paint, I know.
yeah, I thought, yeah, I just wanted to write these two numbers. So I thought it'll be too much of a hassle to open that and write it. So 195, 201, right? This is what customer said. So it is not every time that you would deliver it within these specifications. So all the output here and output here is largely because of the variation which is there in the process. Okay, and this variation in the outputs are caused primarily because not all the factors are within your control, right? Because the factors that we saw here, not everything is within control.
Mm-hmm.
Okay, and because of that, and what is happening is, they do not stay exactly where you set them, and they always tend to change a bit here and there every now and then. So all this is suggesting that the process itself is causing the variation. So at this point of time, there was a major question in front of everyone, which was, is there any way I can control the process and I could ensure that most of my production or most of my output is within the acceptable range specified by the customer? So there was a gentleman called Walter A. Stewart. He came with a concept called SPC. Now, Walter Stewart used to work in Western Electricals, and it happened somewhere in 1930s. And he came up with a concept which was that, if I observe the output and I collect the data from there, and depending on what I want to adjust, if I can utilize that data to come back and control these factors, I can I can control the process as well. And it is very much possible, if I do it quite efficiently, then my production would turn out to be all within the acceptable range or the allowable range given by the customer. So what started happening is, collection of data started taking place, and some aspect of the data people started to look at statistically. and then the feedback from there, the data that they studied was used to try to control the process variation. Now, what is happening is, this entire concept is called SPC, which is statistical process control. So at that point of time, what was happening is, let's suppose there are 6 processes. So I have 1, 2, 3, 4, 5, and there's another one, let's say 6 process. So let's say there are 6 processes. Sometime there might be need to control this one here, the process A. Sometime there might be need to control process C. Sometime there might be need to control process D. Right? Because every time, there would not be the same process which would be causing the variation. Okay, so basically, through the usage of SPC, what is happening now, instead of instead of looking at the process and trying to control the process from the gut feel, now data is getting used here to get the feedback, and the control action is taking place basis the deviation from the expected output. And this deviation from the output is detected statistically by using SPC, or also popularly known as control charts. And this entire process of identifying which factor to control, what is the variation, is called statistical process control. Okay, so now what is happening is, I am not just inspecting the product, but I am also looking at the ways to control the process. Okay, so this is how quality moved up from inspection to SPC, statistical process control. Now, for a long time, people used SPC for good. In sometime in 1940s and 50s, SPCs were, or statistical process control, were used quite extensively by the organization, by the companies. In fact, if you go to a lot of manufacturing houses or manufacturing industry, statistical process control is used, widely there as well. Do you use control charts in in your organization?
I'm sorry.
I was trying to ask, Scott, do you use control charts in your organization?
Use control chart.
Control chart is, I mean, any chart, any time series chart, which gives you upper control limit or lower control limit, anything like that. Have you seen that in your organization?
Yeah, we do. I guess we would, as like talk time and customer service, that kind of thing would be something like that. You have a limit on your talk time that you'd want to limit, and if it's too short, it's not good. If it's too long, it's not good, type of situation. Yes,
it can be used there as well. And so basically what is happening is, let's say for the customer service, one of the prime metric is average handling time, right? So if you're spending too much time on the phone, it is not good. If it's spending too less time on the phone, it is not good as well. So how did they derive at what time is too long or what time is too short? Probably they would have studied the data, the past or historical data.
Correct.
And based on that, they might have come out with, okay, this is the range, which is a good range. If you fall between this particular range, if you call duration fall between this particular range, we are good. If it is above or below that, then we have a problem. Somebody would need to go look at it and try to figure out what is happening. So it is again a concept which has been derived from the SPC, statistical process control. So, coming back to inspection, how inspection has moved to statistical process control. But then, and like I said, it was working quite fine. Everybody was happy. And then, a question came up. How do I know which factor to control? Whether I should control factor A. So if you look at it here, there are 6 factors here. So do I need to control factor A? Do I need to control factor B? Do I need to control factor A and D together? How do I know that? So, then people started thinking, can we actually go ahead and devise a method where we could say that you can leave factors which do not have too much impact on the output and only work on the factors or the combination of the factors which have significant impact on the output. So basically, the ask was to establish some sort of cause and effect relationship. So what people would wanted to find out is out of which of the control factors have impact on the output, which has strong impact, which ones have weak impact, and all this could be done through a technique which is known as design of experiment. So then what happened is SPC moved up to DOE, which is design of experiment. Now DOE is a very different way to improve a process. Through this, you would be able to identify the factors or the combination of factors which are making significant impact on the output. So it's a great technique, and we will go through some of the DOE principles in the Six Sigma Green Belt curriculum. Now there was somebody known as Genichi Taguchi in Japan. He utilized DOE in a very creative way. What he analyzed and what he found, that almost 2/3 of the problem in the process is due to design of the process. As for him, design was a major culprit. So the focus shifted from the process to design of the process. Now people started worrying about the optimizing the design of the process, the design of the product, or design of the process itself. So they tried to find out, excuse me, which of the design factors were really the influencing factors, which out of these were the critical ones. This can be found using DOE, because DOE can help us to find out which is the critical or the significant factors. So in the design development, DOE became a big tool. And all this was again first done by Genichi Taguchi. He came up with special type of design. One of the design is called robust design. And these are, as I say, very special design. They hold on to their performance even if any change, even if there is any change in the environment. So then the inspection reached the Taguchi methods. Now again people started thinking, people realized that we can have all these techniques, but we can put things together, things like people, machine, material, etc. But unless there is a proper management system, things would not work effectively. So again, people then turned over to the new leaf, and what they figured out is that we need to have a suitable management system in place. One of the quality management system is called TQM, and there are other systems like ISO 9001. It is also called the QMS, Quality Management System. You heard about TQM or ISO?
Yes, I've been involved in ISO, so I'm familiar with ISO.
All right, perfect. So, ISO, again, just like TQM principle, it gives us certain processes. If you follow that processes, you would end up with a good product or good service. Although these systems, they do not directly control the quality, but they provide you the framework, the guideline at managing the systems. So if you go through the process of TQM and the steps of ISO, you would end up with a good product, good output, good customer satisfaction level. This is something that would consistently come along if you follow a good management system. So many companies started taking this route and put into practice various management systems. In many cases, what happened is it turned out that it did not impact the bottom line of the companies. The reason was that these were sold.
Hey, Admit.
Hey, Scott, can you hear me?
Yeah. Can we go back to where you jumped from TQM to Six Sigma? I kind of lost you.
Oh, okay.
Yeah,
right.
I didn't get.
So I did not. Right, I did not reach Six Sigma. I was still at TQM. So what I was saying is that Okay, so there were many companies who started to put into practice the various management system, and eventually what they realized is that these management systems, they're not impacting the bottom line of the companies, and one of the main reason, because these were presented as philosophies, and it was not presented as the tools or techniques which will actually go ahead and impact on the bottom line. So, what started happening is companies started to, to leave these aside. Then, of course, there was a big problem that came about. People started exploring how do we change things. More importantly, how do we impact the bottom line? That is when Six Sigma came along. So, when Six Sigma started, people were able to see that it really has impact on the bottom line, on the dollar value, because it is conceived, planned, implemented, and executed in a very special way. Ideally, a Six Sigma project cannot be started unless and until you can foretell or project the impact of that particular project on the bottom line. Unless you can do that justification, you cannot start a Six Sigma project. And when project is completed, you would need to assess it and find out if I really reap that much amount of savings. This is something which was a must for every project, and this approach was very different from the TQM approach, because TQM essentially talked about good practices. It's like for good health, you need to walk in the morning, but we really don't come back and make the measurement. TQM was actually packaged and presented like that. If you do certain things, that will have a good impact on the quality, but people were not able to uh, see those results on the bottom line, and all this got changed with Six Sigma. Six Sigma is actually launched project by project. It gave a framework on how to select the project, what and which project to choose, how do you work out on the justification, how do you execute the project, and then you come back and verify, yes, indeed the result materialized. And this is done by Six Sigma. So this is how quality evolved from inspection to a Six Sigma, wherein started with the inspection, wherein nothing else but except checking of what has been produced took place. The moment there was a mass production, SPC came into picture, and when the focus shifted to the process to try to find the factors which are important, design of experiment was used. And if a good design need to be produced, a good design of parts, good design of product or process, Taguchi method was used, and then it moved up to the good management system like TQM or ISOs. And as we talked, that having the management system would not be enough, and it will not produce a profit. That is when Six Sigma started to manage the quality. So this is where we are right now. From inspection, we are at the stage wherein Six Sigma is actually managing the quality for most of the organization, irrespective of the industry or the domain that we are working in. Any question on this slide on evolution of quality before we move ahead?
No, I think I got it.
All right, perfect. So I will move back to my original presentation.